listening in. Hope you guys are having a great Friday and looking forward to kind of kicking off the weekend in style. For those of you that tuned in last week, we'll be covering a portion of similar content. We'll be much more focused on lithium-ion storage for other applications. So hopefully we cover all the bases for you guys. And as those of you know, if you've been following our webinar series, you know that I like to kick off with just kind of an overview and agenda of what we'll cover today. So getting started, I think first off, whenever we talk about lithium-ion storage, it's important to talk about, this is a little meta, but it's important to talk about, well, why are we talking about this? Why these chemistries, why this type of storage, why a change from what we've been doing for decades now. Also very important from my perspective to talk about different applications. Solar plus storage is not universal in what it can do and why and how. So it's important to differentiate between those two things. If any of you guys have ever called into our tech department and talked to Glenn or Brad or Aaron, you've probably had them ask you, well, what are you trying to do? It's a critical question we've got to ask to make sure we're specifying the right material that the system is designed to perform to do exactly what you need it to do. With lithium ion, it's still a relatively expensive solution. So if you're not taking that specific use case into account, you may end up with really pretty wall art if you're not taking the right application into account. I want to touch upon just real briefly available chemistries, and I'll send this out with a huge disclaimer that I'm neither an engineer nor a chemist. I try to learn as much as I can and aggregate that and share my knowledge with any and all of you. So this will be a very 101 level on available chemistries. I think it's important to differentiate between the two. We'll spend the most of our time today on the current storage offer. So what do we have available? What are some different brands? What can they do? How can they fit those applications? And then perhaps a sneak peek on what's around the corner. What are some things we're looking forward to in Q3 and Q4, and how can they help? So with that said, let's get kicked off. So why lithium ion? Why do we keep having these conversations about the storage itself? Why all the buzz? Well, obviously lithium ion continues to get a lot of buzz. A lot of this is driven by some really high profile marketing and awareness around lithium ion storage for electric vehicle applications. You're starting to see it much more prevalently now in behind the meter or utility scale storage. There was a recent project, well, recent, but it's been a few months now, in South Australia, where some really high volume power packs were installed to help with load shifting and some other applications there. Generally speaking, getting back towards the chemistry, buzz and PR is typically not enough in this industry to get people moving, to get them migrated from one technology to another. I think solar is, I give solar a lot of props in that, for most people, if it doesn't make dollars, it doesn't make sense. And in that, I mean, there's got to be clear-cut functional advantages for people to prefer a technology over another. The marketing aside and the buzz that you're getting from homeowners, you guys are smart. You know that the proof is in the pudding, and there's got to be clear-cut advantages to one product and moving to that over something else. So, in my opinion, where lithium-ion clearly excels over lead acid or an AGM product, energy density, and we'll get into these in the next slide. Charge and discharge capability and cycle life. So I think in none of those areas would you necessarily rate your typical lead acid chemistries as strong performers, and really just clear-cut advantage over those that lithium ion shares. So what do we mean by that? Energy density. You could say energy density, you could say specific energy, but basically what we're getting to is energy or power per kilogram. So I got some, I use these because the source here from Victron Energy, great blog post on kind of getting down to the root of the matter and how does lithium perform and what are the relative advantages over lead acid. So top left, energy density. It's 2 points here that I want to try to unpack for us. You see here the scale on the right, a lithium-ion chemistry, and I don't recall exactly which one he's pointing to, but I think the energy densities are close enough on LFP and NMC that it's kind of irrelevant. But basically, what he's got here is at a 48 volt bus, 400 amp hours, without packaging, if you will, without converters and things, 336 kilograms. The equivalent amount of storage to be able to provide the equivalent effective usable energy in a lead acid chemistry would be 1,300 kilograms. So there's 2 points there I want to make. One is amp hour per amp hour, lithium's going to weigh a lot less. It's going to have a much smaller footprint. The other point is that due to discharge capability and depth of discharge, on a lithium ion pack, you're going to be able to discharge that, 90+% regularly without harming the battery. That was the intended use case. The chemistries that were designed for that. As most of you know, on a lead acid front, if you're intending that battery bank to do regular cycling, you're really not going to want to plan around a depth of discharge more than 50%. If you're using it strictly as backup and you've got a kind of a set use case and it's not going to cycle more than a couple times a year, you can plan around an 80% depth of discharge. Even still, 50 or 80 versus 95 plus, it's clear you can be able to get more usable energy out of the same nameplate capacity in a lithium ion battery, in addition to it weighing less and taking up less space. I won't elaborate on the maintenance components as well, because we've got some really great AGM batteries out there that are effectively maintenance free. But suffice it to say, no maintenance needed on lithium ion. The next point I wanted to try to make was in the lower left, so charge discharge capability. One of the reasons I really like steering people to this blog post is he does a great job with his infographics. And on the top here, you see you see a typical AGM chemistry, and what he's shown here is graphically he's shown here is the effective usable energy in a given nameplate capacity at different discharge rates. So a couple different ways to think about that. Typically, we would talk about lead acid AGM chemistries in terms of hour rates. So what's the amp hour rating at a 100 hour rate? If I took this battery and I only discharged it, I discharged it over a span of 100 hours, how much usable capacity would I have? 20 hours is pretty standard for our applications, off-grid, or battery backup. So at a 20-hour rate, you see there that the red proportion of that cell is basically unusable energy, energy that's created, that's turned into heat through the discharging of the battery. And you see there that as you work towards the right, the C rates increase, the amp hour rates decrease. So effectively what you're saying there is the harder I discharge this battery, so the more quickly I pull the energy out, the less usable energy I've got. And you see there, if you're using a lead acid battery at a 20-minute rate, so you're going to discharge that whole battery in 20 minutes. One, you're getting very little usable energy out of it, and you're probably going to kill the battery in very short order. On the other hand, what you see from on the lithium ion chemistry down at the bottom is manufacturer guidelines respected, of course. At a 0.5 C rate, you're still getting that full usable energy, maybe a little more depending upon how they've conservatively rated the battery. And you see very little degradation even at much higher C rates. So you don't necessarily want to plan your system around a 5 C 12-minute rating. That's going to be more for things like hobby equipment. It's going to be more for UPS type batteries. But even at a 1 C rate, you're still getting the full usable energy out of that battery. That's really the reason. the charge discharge capability, the energy density, in my opinion, as a layman, really why these batteries, the nickel, manganese, cobalt chemistries are such a great fit for electric vehicle applications. One, you're getting a ton of energy and power in the same, in a footprint and in a given weight. Two, you can discharge them very rapidly and see little degradation in the battery and see little degradation in the usable energy. The next point on the right, and I should have put a huge asterisk with this because every battery is different. Every manufacturer rates them and warranties them differently. And I think this is where there's been the most water cooler talk or chatter around lithium ion is cycle life. The way that AGMs and lead and flooded batteries are rated is not rated, but rated is they'll give you an amp hour and they'll give you a cycle life. Lithium ion's a little bit different in how those are typically warranted and rated, but very, very good cycle life performance. So working from the bottom up, gel batteries, meant for real deep cycles, fewer cycles available in a 12-volt format. As we work our way up to AGMs and floodeds, you're getting 500 to 1,000, maybe up to 2,500 cycles out of a 2-volt gel. LiPo is a chemistry you're typically only going to see. Well, I've only seen it so far in model airplanes and model cars and things. LiPo being lithium polymer, much more conducive to being shaken and jarred and moved around. But great performance. I've got a great anecdote if you see me at one of our trainings or whatever about retrofitting an old model car with lithium polymer electronics and how much fun that can be. Lithium iron phosphate at the top of the chart there in high performance, great cycle life. So you're getting the cycle life, you're getting the more usable energy at higher discharge capabilities and a lower energy density. So you combine all those things together, and it's it's a pretty clear use case for most solar plus storage applications. So I want to dive a little, real briefly into the two chemistries that we're predominantly seeing in solar plus storage space. On the left, I'm going to try not to butcher this pronunciation, lithium, nickel, manganese, cobalt oxide. And you see there the chemical formula there. On the right, lithium iron phosphate. So the products that we typically see on the left are going to be, of course, the Tesla Powerwall products, the LG Chem lineups. On the right, you're going to see products like Discover Battery, the Enphase IQ battery, all of which we're going to cover today. There's some other products out there like Sonnen Battery, like Iron Edison's got one as well. So the cell voltages are pretty similar, and the C rates can be similar in terms of what are they rated for, how quickly you can be able to discharge the battery. These radar charts that I got from Battery University are a little bit more, some generalizations on the chemistries, but will give you a little better indication of what the differences are. So specific energy, what we mean by that. This is a chemistry term I had to look up. So the energy per unit of mass, specific power being the rated power per unit of mass. Energy being, of course, watt hours or kilowatt hours, power being amps and thereby watts. So on the left, where does NMC excel? Specific energy, specific power. You see that it's got a pretty good lifespan, good performance, pretty good safety. Both of these chemistries are going to be similar in cost. And this information is from, I think, last year. So cost is always relative, of course, and it's going to vary by manufacturer, by application, by power rating, by scale, etc. On the other side, lithium iron phosphate, where does that have a relative advantage over nickel, manganese, cobalt? Specific power. So again, the power in terms of wattage or amperage you're going to be able to pull out of a specific mass. lifespan. You're probably going to get a few more watt hours through that battery over its lifespan, and safety. And you've seen some marketing coming, back and forth between these two chemistries on relatively speaking, which is more safe. I guess my perspective on this is, sure, if you drive a stake through a nickel manganese cobalt, it's not going to like it and you're going to have problems. But I think the takeaway there is don't put a stake through your battery and you'll probably be just fine. Initially, when NMC batteries were starting to come to prominence with Chevy Volt, with Boeing, with the Samsung, what was that, the Galaxy Note tablets and phones, we saw we clearly saw some issues with that. You started hearing about the term thermal runaway. If you've ever been to one of my trainings, you've heard me preach about the importance of going with a quality, name brand provider, making sure that there's it's a brand you can trust and that they've done a good job on the battery management system. So the BMS is really going to be critical in our storage, our solar plus storage applications, where the inverter is going to be making decisions based off of either the voltage it sees off of that pack, or the instructions coming from the BMS system that are going to tell the inverter current state of charge, battery temperature, discharge rating, etc. Without those communications, you're placing bets on an inverter being able to make really precise calculations on voltage. And unlike lead acid chemistries, where the voltage will sag under load or will rise under charge, the voltage on lithium ion, both chemistries, is relatively stable. So you're talking about fractions of a volt between fully charged and almost all the way discharged. And most power electronics are not sensitive enough to be able to make decisions off of those small fluctuations in voltage. So takeaway here: make sure you've got a provider you can trust. Make sure they've done a good job on the BMS. If at all possible, you really want to make sure that your battery BMS and your inverter are going to communicate to one another. For those reasons, that's really why we've picked the products we have. We've picked products that we knew we could get behind. We've picked products that fit, that check off those boxes of quality provider, good BMS, communication with the inverter. We want to feature products that we're proud of, that we feel confident in, that we know are going to serve you well. And that's why we've picked the providers we have. So moving on from chemistries to applications. This is where we get back to that question around, well, what are you trying to do? In the olden days, and for me, the olden days is 2012 when I got into this industry. There were two and a burgeoning third application. First application, being the oldest, and at that time the most prevalent, was off-grid. So pretty simple here. What is off-grid? Well, it's used to deliver reliable AC power. Well, there's no grid. So mostly used with PV, but we've also had a long history of off-grid storage with wind, with micro hydro. I won't say ground source heat pumps, but there was some thermal in there as well. Predominantly what we're seeing now is PV, because the prices have come down so far. It's a readily available technology, and there's very little other engineering to do. So you're not having to do mechanical engineering on wind loading for turbines. You're not having to do geological surveys, etc. Really driving the PV plus storage application for off-grid. Battery backup. So, there we're storing energy from PV and or grid to provide power in the event that backup is needed. So inclement weather, storms, intermittent grid. We're really fortunate in North America here to have a very stable grid where I'm in Northern California, and we've maybe got 3 hours of grid outage a year. And it's typically for no more than 10 to 15 minutes. Part of that is I live in the suburbs, and most of our feeders and transmissions are buried. If you're in a more established neighborhood and you've got distribution wires running through your neighborhood, you're going to be more susceptible to, limbs falling, transformers going down, etc. All that wrapped up, though, unless you've got inclement weather you're probably not having to deal with outages and situations that we see in other markets like South Africa, where they've got rolling blackouts. I digress. So battery backup typically used to back up critical loads within a home or building. So you're peeling off some of those loads from your main panel. You're putting them on a backup sub panel, a critical loads panel. In no particular order: medical equipment, maybe some refrigeration. We've seen systems designed specifically around keeping a customer's prized wine collection perfectly climate controlled. I've heard, I've not seen this system yet, but we hear about systems in Hawaii for fish tanks and koi ponds and things. So that's backup. Now, self-consumption is kind of a catch-all for everything else, in my opinion. If you listed all of these out, you'd have 9 applications. This is most of what's driving the boom in solar plus storage, and it all has to do with kind of cutting-edge grid capability. Application number 1, time of use rates, where you're trying to shift loads from one time of the day to another. Rather than using a load controller and actually not performing those tasks, you're using storage to store the power needed for those tasks at a different time of day. This is a very energy intensive application. It's going to require a ton of power. Demand-based rates. So we see this a lot in commercial, although we're starting to see it in utilities like Salt River Project, where you've got an energy component on your bill. You've used X kilowatt hours in these tiers, therefore your energy portion is this. You're also now starting to see demand-based rates where, given the automated meter infrastructure they've got, they know in a 15-minute period your peak kW that you're pulling off of the distribution system, and they're assessing you a fee based on that. So the name of the game here is putting some of those loads behind storage and making sure that they're not driving up your peak kW number. For commercial, this can be a huge proportion of a customer's bill, and your typical net metered PV is going to do little, if nothing, to help mitigate those demand-based charges. Another couple here that are kind of interrelated is a low feed-in tariff, and we see this in some markets where the utilities and the utility commissions have collaborated to pull back the feed-in tariffs that people have been grandfathered in. We've been pretty fortunate in North America, but we've seen this in some other markets like Australia and Germany, where the utility says, I've got more than enough generation. I'm no longer going to pay you for what you're putting onto the grid. And in situations like that, you see some ornery, stubborn homeowners who say, well, if you're not going to pay me for it anymore, fine. I'm going to do an energy storage retrofit. I'm going to use that power later in the day, and you're no longer going to see the benefit from me. Net metering not available. Again, not terribly prominent here, but I think this is the future we're unfortunately marching towards, where you'd be allowed to use your own generation, of course, for your own loads, but they may or may not even allow you to net meter back to the grid. The huge example there, obviously, being Hawaii, where you're simply not allowed to export back to the grid. And then specialty programs like SGIP, targeted incentives for giving storage behind the meter. All of those things are really driving the applications we see today, and driving how do I want to say that? A tighter bill of materials, a more cost-effective bill of materials than we've perhaps seen in the past. This is the point where I'd have to talk a little bit about application stacking. So in few markets in the United States would you see that the applications on the right under self-consumption would be enough to really justify a solar plus storage system. In almost every market we're in, we're having to combine one or more of these aspects of self-consumption with backup. I think when you get down to it, the economics are such that, adding storage doesn't pencil out just based on energy arbitrage for time of use or getting a rebate from SGIP. You've really got to combine that with a practical advantage like backup that you can sell a homeowner. Now, I started off this conversation by saying we're very privileged in North America to not need backup a lot, but you know, most folks have some outage story, or you know, you're working off of headlines around hurricanes and superstorms. And if you can provide backup cost effectively, a lot of times that's what gets the sale kind of over the hump and closes the deal for you. So those are the applications we're looking at. Let's get into the meat and potatoes of what we're here to talk about, which is product. I'm a product guy after all. The first one we wanted to lead off with is the Enphase IQ battery. So this is a product line extension. This is an evolution of the original AC battery from Enphase. It's got the same, you know, advantageous modular design. Each of these units has 1.2 kilowatt hour rating, 280 watt power, integrated microinverter, using the updated IQ architecture, really lightweight. I don't have the dimensions up here, but you know, they're roughly, I think 18 by 24. You know, pretty easy install for a single guy working in the power electronics, you know, space of the install while everybody else is up on the roof. 99% depth of discharge, really good round trip efficiency, and this is something that's not commented on a lot when we talk about storage. Is on a DC coupled or an AC coupled architecture, your round trip efficiency is going to be much higher on the I'm going to pause and not misspeak. It can be a lot higher on the DC coupled architecture. It's really an instance where you're going to have to kind of map out your design and think pretty critically about what's the route the energy is taking. Are you using it concurrently, or are you storing it for later? And I've got some great material on that if you're interested. LFP, so lithium iron phosphate chemistry, great warranty here, 10 years or 7,300 cycles, which is quite a bit. I don't know a lot of applications right now that are calling for that many cycles. Good warranty, quality product, and you know, I think the great advantage here is the distributed architecture, which you know we'll kind of show here. So if you've had any experience with Enphase, if you've talked to them before, they're huge evangelists around distributed architecture. I've seen some stuff in their lab I'm not allowed to talk about, but some really powerful stuff they've got coming, hopefully Q1 next year, in a distributed system that you know will really blow your mind. So I don't want to talk about it too much, but I've seen the roadmap and it's very powerful. So again, the great advantage to the IQ battery, you can install one, you can install 0, you can come back and install more later. They're flexible, they're modular, and it's a, relatively speaking, very simple retrofit to an Enphase system. And of course, you see everything kind of all at once via the Enlighten application. Yeah, so product we're excited about. Let's move forward. Got some slides here on our most popular lithium-ion product right now, which is LG Chem. And there's a couple different flavors here. The 10H Type R, up until now, there's been no reason to kind of refer to it as Type R because it's been the only Resi 10H that's been on the market. The Type R standing for RS485. That's the communication protocol between the LG Chem Resi 10H and the solar+storage inverter. I talked a little bit earlier about really making sure that you've got a good quality interface, if you will, between the battery and the inverter, so that the inverter can make smart decisions on what to do with that energy, charge, discharge, idle, etc. 9.8 usable kilowatt hours, outdoor rated, but I would strongly recommend you find a place for it indoors. Any battery is going to be sensitive to changes in temperature. They really don't like cold weather. They're not particularly keen on really hot weather either. And it's a beautiful unit. This is expensive equipment. Let's take care of our things. I'd recommend installing it indoor if at all possible. aesthetics are relative and they're of course subjective. I think it beats hands down anything you're going to be able to put together in the lead acid space. Good warranty on this. So I spoke a little earlier about different ways of rating and warranting products. The warranty on the LG Chem is 60% usable capacity after 10 years in normal cycling. So 60% of 9.8, call that 5.8 or 5.9 usable kilowatt hours after 10 years. That's exceptional. Think about the usable life you're getting out of your phone, and compare that to what we're looking at here, and you see that LG Chem's really done their homework on the chemistry, as you'd expect from a company like that. So two, maybe versions isn't the proper word to use, but two models of the LG Chem Resi 10H Type R. There's a primary, and there's a secondary. Secondary being if you want to do a larger 2-unit system, so you want to pair two of these batteries for one storage inverter. They're not identical. There's some slight differences in the controls and how they communicate. One will be a primary, one will be a secondary. Master slave, I think, is the terminology you typically see for these products. The primary available through AE right now. The secondary will be available very shortly. LG Chem's a very considerate, very conservative company when it comes to launching products, and we've had these in beta testing for a few months now. They really wanted to make sure that any firmware issues that could crop up on how you monitor 2 batteries through one portal would be properly addressed before releasing out to the market. We're optimistic that we'll be able to release these in the next month or so. So very excited about that. A little bit more about the LG Chem Resi 10H. I'm not going to go through these points. This was mostly here to make sure that you guys had it for follow-up slides and for your own edification. This is pasted, I'll be honest, this is mostly just cut and pasted from the installation manual. So if you didn't want to download that, you'll have it in the slides we send out to you after the presentation. So you were probably wondering, well, if that's the Type R and we've never talked about types before, what else am I looking at? Type C, going to be coming out real shortly here. So what's driving that? The SMA Sunny Boy storage product coming out imminently that we're very excited about. So, internationally, and SMA is, a leader here as well. It's much more prevalent for these products to be communicating over CAN bus. CAN bus being a protocol language that's used a lot more predominantly in automotive. So some slight differences in how the units communicate. Unfortunately, they weren't able to do this via jumpers or firmware. It had to be a manufacturing difference. So I want to call it again. These batteries are not cross-compatible. You need to make sure you order the right battery for the right inverter. And you'll see I'll show you guys in the part numbers later what you want to look for. Additionally, the Type C will have some slightly different parameters than you'd see on the Type R. So higher voltage, lower current than you'd see on the Type R. You're still going to get the same usable capacity, same aesthetic, same form factor. You can still use the same lifting handles. I didn't feature the Type C battery because externally it's indistinguishable from the Type R. A word of note here, and I'm probably going to butcher some of the specifics on this, but the number one, and I won't really call it an issue, the number one note we've had coming back from installers and from LG Chem is to really take your time of commissioning, cross all your T's, dot your I's, and be very mindful to turn things off, breakers and switches during commissioning. I think that the typical tendency when we're commissioning things, we're hands-on, we're eager, is to get everything strung and wired, of course, have everything mounted, and then, of course, you want to turn it on and make sure it works. And in a lot of instances, installers have not turned things back off while they're waiting for PTO or while they're waiting for inspection. If your battery switches are on and your inverter's off, The battery is going to want to power that onboard DC converter. It's going to want to power all those control circuits, and you're going to end up bricking your battery and having to call LG Chem to bail you out with a swap or a recharge. So if you've got questions on that, please reach out to the folks on my team and we can walk you through it. We've got good work instructions there, but I'd be remiss if I hadn't mentioned that. So lots of great things from LG Chem, and good partner, great feedback in the market, and I think the numbers that we're seeing on S-chip installations really bear that out. So we've talked for now about products, primarily geared around self-consumption, backup. What do we have for off-grid? If you tuned in last week around what's new in off-grid, you saw these, you saw much of what I'm going to feature. If you didn't, here it is for the first time. So we've now got a plug-and-play drop-in lead-acid replacement with a good lithium-ion chemistry. So the Discover AES is a battery pack that, like I said, drop-in lead-acid replacement. You're going to see dramatic improvements in cycling, in charge time, in weight reductions, in those typical off-grid and I'll say off-grid and battery backup using quote unquote off-grid equipment than you'd see over lead acid. So the marketing here from Discovery is dramatic improvements in cycle life, in charge efficiency, with zero maintenance requirements, and all of that's going to combine for a lower levelized cost of energy. So what is a Discover AES? I've got here a real life installation that comes from a customer, not a lab, not a mock-up, not a demo. I like this because this guy did a great job at making it neat and tidy. One of the things here that's just so different from your typical lead acid installation is everything's off the floor. You've still got, a usable footprint. If you wanted to, you could, I've got young kids, so I think about where am I going to store all their, Hot Wheels and toys and things. Bam, I've still got my usable floor space. The installer's also done a great job at using, at putting a lot of this stuff kind of behind the wall. So you don't see a ton of conduit going from the XW Plus to the disconnect. You see there, he's got some looming to do on the communication wires from the packs back to the comm box, but very tidy, a really small footprint for the usable energy he's going to get. That's each of these come with 6.6 kilowatt hours of usable energy. So that's 13. Your equivalent on lead acid is going to be much bigger, again because of the depth of discharge capabilities and the specific energy. So what is a Discover AES? Integrated lithium iron phosphate pack designed as a drop-in replacement. If you're interested in chemistries, we spoke a little bit earlier about, kind of nominally around 3.5 volts per cell. So the way they get to that is strings of 16 cells to get up to kind of a 48 volt nominal, and then they're going to parallel them to get the current up to be, usable with today's equipment. CAN bus or ZAN bus enabled BMS. So we spoke a little bit earlier about, CAN bus being a, kind of predominant language for stationary storage automotive. ZAN bus, a proprietary language specific to Schneider Electric. The reason that's important is you've got, what I would call over-the-counter products that will communicate with each other from different manufacturers. So first real example of that from the, predominant, legacy inverter charger manufacturers. So very excited with that. We've also seen some customers speccing out ZAN bus specific Discover packs using and I'm going to use my mouse here on the screen, using the Schneider Electric comm box for monitoring, and then coupling that with other equipment. So that is, that certainly was in the wheelhouse of what Discover can do. High cycle life, 4-year unlimited cycle warranty. I don't have on here the balance of the warranty, but I think if you make some reasonable assumptions about how many times you're going to cycle this, you'll see kind of how many years you're going to be able to get out of this and how many cycles. High charge discharge ratings. 130 amps continuous, 600 amps for 3 seconds. So you're going to be able to turn on powerful loads. You're going to be able to support the high surge ratings of, your typical off-grid product. Again, really addressing a lot of the capabilities you'd be able to see with a quality AGM or lead acid or flooded lead acid battery in a much smaller format, with much better specific energy and good depth of discharge. I'm doing a time check here, and we're running a little long, so I won't belabor too many of these points, but real big value prop for Discover is maintenance-free operation, something you're just not going to see with a flooded lead acid. Plug and play with ZAN bus, and I've heard from both parties that they're working on integration between, software integration, of course, between Outback and Discover battery. So eagerly awaiting that. We're big Outback power evangelists here, and have been eagerly awaiting, some capability around lithium ion. We talk here on the left about maintaining capacity and voltage across a lot of different discharge scenarios. On the right at the bottom, thriving at partial state of charge. So, historically in flooded lead acid and AGM chemistries, we haven't seen good performance at partial state of charge. We've seen some, carbon-infused battery chemistries that really address that and improve it, but certainly not at the level of what you'd see from a lithium-ion pack. So, great incremental improvement over the existing technology out there. Let's Discover, something we're very excited about. We've had them in our portfolio for a couple months now. We've been speccing out a ton of designs. Seems to be working. They're shipping out. We don't stock them, but we've got great drop ship capabilities, short lead times through Discover, and in my opinion, some really reasonable freight quotes as well. So we've covered 3 different product families, a couple different variants. I want to show you guys what part numbers. I'm not going to read all these off. Wanted to make sure that you guys had them in these notes that come out to you after you complete your surveys. And I wanted to touch briefly around what we think we're going to see in Q3. So an SMA compatible product from a company called BYD. It's a big provider into the battery space in Germany and some other markets. We've been eagerly awaiting that, and we've got some beta units we've been testing. 3,800 watt storage hybrid inverters, which will of course work with the LG Chem Resi 10H Type R batteries. I didn't put this on here because I didn't want to paint myself into a corner, but we're also optimistic around the launch of Mercedes-Benz Energy lithium-ion packs. Those will be, we're hoping to see those in Q3. That's another one we've been eagerly awaiting. I like having options in terms of, different platforms that things can work with, in terms of, not putting all my eggs in one basket. So, yeah, very eagerly awaiting all 3 of those products. Now, at this point, I'm going to move ahead and open things up for questions, because I'm sure there's more than a few.
Thank you, Josh.